Niagara Conservation has some of the lowest flowing and affordable but conventional toilets in the world. Introducing the Stealth, we have a 0.8 gallon per flush, single flush toilet as their main product, and then a new dual flush toilet that goes down to 0.5 gallons per flush. You cannot get any lower than this without risking backups. Using vacuum-assisted technology and other innovations, we have glowing reviews from affordable housing renovation developers who only spec this toilet because it is more durable than conventional toilets and helps reduce the growing water bills that directly impact low-income residents. You know that these toilets work in these situations. They will work anywhere. Not only that, but new, you may have not heard of this, the original Stealth now has a durable side handle instead of the button on top. Innovative and stylish, this adds timeless elements to what is otherwise a very forward-thinking toilet. These toilets are also fully ADA compliant, or can be, and ensure that the trending integration of accessibility into green building happens. Bonus, Niagara and AM Conservation have WaterSense certified 1.25 gallon per flush shower heads, 0.5 faucet aerators, and 1.5 sink aerators for new and existing buildings. These low flow devices feel like normal ones and not only save water, but also can reduce energy through unneeded heated water. All right, so welcome to the basics of designing and rebuilding, so new construction and renovation on the concepts of a no utility bill home. This course is just real basic. We're just kind of highlighting what it is that you need to do to get there, and we're reviewing what others have done, what we've seen out there. A lot of this focuses on cold weather climate homes, but the interesting thing to know is that if it can be accomplished in cold weather climates, you're going to have a lot less you have to do in warmer climates where you have less heating and cooling demand loads. So a lot of our work is in the colder climates, so a lot of our references come from there, but we are seeing more projects down in the 4 and the 3 and the 2 climate zones as well. So this course is approved for 1 hour in continuing education units. And today I'm not just the moderator, as I usually am, but I'm also the presenter of this session. And I am the executive director here at the GreenHome Institute, and we are a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. All right, so let's get going. Thanks for joining us. The first thing that we've seen and we've talked to and we've noticed as to get to zero energy is the very first thing that you have to do is to commit. A commitment has to be made by the owner, by the developer, by the builder, the architect, the project team, and even everybody else involved. There has to be a clear definition of what you're trying to accomplish and a commitment. So there are several programs out there that can help you put together a framework on how to achieve your goals during the design or during the the renovation stage, before renovation, as you're putting your plans and specs together. The very first one, and the one that's probably the most internationally recognized program, is the International Living Future Institute's Net Zero Energy Building Certification. This is sort of a high-level, idealistic certification program that not only looks at design and certification that's beyond LEED Platinum, but also requires an actual full-year time of a utility assessment, and you actually have to show that you produce more energy that you used. And this actually is a certification that can be used for homes, for anything. I mean, it can be used for boats, I guess. So it is available out there for many different applications. I would say it also goes beyond zero energy and looks at other things that aren't just necessarily focused on the building and energy efficiency. And it's not as intense as the Living Building Challenge, but it does look at saying if you're building on green space, for example, they won't let you do that. So there are some restrictions with this program, but it's probably the most recognized one. Underneath that is our GreenHome Institute Zero Energy Capable certification, which just needs to show through design, construction, and testing that the home or building can meet zero energy, no utility standards over the course of a year. And then Earth Advantage, Zero Energy Certified Home, has some great prescriptive requirements for their climate, I believe, mostly for the Portland area and surrounding climate zone, I think 4A over there, on how to achieve zero energy. I think it's still a beneficial program to take a look at, but I believe it's focused on the Portland area. You'll also see me reference the Department of Energy's Zero Energy Ready Home program throughout this session. That program is not a zero energy program. Rather, it's a program that gives guidance, design, and full-fledged certification to show that a building, or home rather, is ready to go no utility, ready to go zero in the future once the cost of solar comes down, and then it's just a plug and play that you just put the solar panels right on. And then, of course, there's other local programs that exist that give guidance and certification to zero energy, and I suspect there's more national ones and international ones that are growing day by day. These are just a few that we're going to be referencing during this session. All are good, helpful programs that, again, if you're going to be making the commitment, you can use it as a guideline and a framework. So this is the Burbeck at Beacon Springs project in Ann Arbor, Michigan, and while they haven't went through a full year, you can see just up until January through this past summer, they've already, they have a net gain of nearly 4,000 kilowatt hours, and they have no gas, so there's no CCF involved in that. You can check out their website at beaconsprings.org. They are pursuing the Living Building certification, LEED Platinum, and the Zero Energy Capable program. And one thing that they did is they got the project team together way at the beginning and started asking a lot of questions and started making the commitment. I remember all of the emails flying by. And they got all of these folks together, and they determined that they're going to need all of these different skill sets to, again, commit and then to communicate the goals with each other during several different meetings during the design and pre-design stage, and then ultimately assign accountability and make sure everybody's held responsible to play their role. And this is huge because I think this is the biggest problem to achieving zero energy, to be honest, and that's why I'm starting with it, is that having lack of commitment from somebody on the project team. And of course, you might have a smaller project where, one person is playing many roles. And so that helps, that helps if they're committed. But if there's somebody who's not committed, who doesn't understand their part and how they fit into the goal, it certainly can cause a lot of problems, a lot of hangups, and ultimately a lot of failures. And a lot of these certification programs require that these preliminary meetings take place. And so you might also notice at the bottom here are two new folks that you might not normally see on the team. And of course, that's the solar energy expert and then the home energy assessor that you're going to definitely need on the project team. And believe it or not, the landscape architect does play a role in that because there are opportunities to design landscape that can either work with the home or work against the home. And so even the architects, the landscape are going to be playing a role in all of this. So here's just a list. If you go to the Burbeck's website, you'll see some information about everybody on their project team. They're pursuing full Living Building Challenge certification, so they're going to have a lot more folks added to this, but you can kind of get a sense for how many different energy consultants they had to help them out, and how much talent and input needs to go into the pre-design, to make sure that you get the performance that you're looking for. So second to the commitment, I would say the next biggest thing is you've got to know your current solar income. You've got to know what your limitations of your site that you're building on, or if you have the opportunity to select a site, it's almost like looking at the multiple listing service when you're buying a house and you're looking at all these features. Well, in this case, you would be looking at the features of the site selection for current solar income. This is Matt Grokoff with the Mission Zero Home at happyhome.how. This home is certified net zero under the International Living Future Institute's certification. It's a zero energy capable home, and it's a Green Star certified gold home. This home has achieved zero energy over several years. They've had a few hiccups here lately with some of the modules failing on the solar, but they have nonetheless achieved zero energy and no utility costs and made a net positive surplus of costs while driving a Bolt. This is a 115-year-old home that they put a plan together to reduce the energy and ensure zero energy on the house. And I would argue that a lot of the things they did 5 years ago, the costs are probably half now to do those kinds of things. So they've really paved the way in this Ann Arbor home. What's interesting though is what they first started is they said, what is the solar income of our lot and the roof orientation of our house, and how much solar can our house produce as far as kilowatt hours a year. And they had to work backwards from that, because they knew whatever those kilowatt hours were, they had to say, well, we've got to design energy efficiency strategies to meet those kilowatt hours the rest of the way to then add the solar on. So a lot of folks will come in and say, well, here's all the things you have to do, and then hope that you put enough solar on, whereas they sort of were very intelligently worked backwards and used the National Renewable Energy Laboratory's PV watts calculator to say how much solar power is hitting our site. So this is a free tool you can check out at pvwatts.nrel.gov, where you go in and you drop in the address of the existing site or the new lot. And then from there, you're going to, and this isn't Matt Grokoff's house, but from there, you're going to draw a picture basically of the roof pitch or of the lot if you're doing ground-mounted solar, or of the flat roof. And then you're going to tell the system a couple different things, and it gives you a bunch of free guidance on what to do, and it gives you some estimations. So if you're not a solar expert or you're not working with a solar expert, you can start to do some basic estimations on what the size is, what kind of modulars you're using, what direction those panels are facing. You have to make sure to tell it what direction those panels are facing, and then out it's going to spit out your average predicted kilowatt hours per year. So this is average. Obviously things can change if it's a more sunny season or less sunny season, but what they're doing is they're sort of giving you the average to work with, so you know, again, what it might cost you, and how, if you're trying to get no utilities, how low you have to design your building to. And so yeah, the question is, what is the website again? pvwatts.nrel.gov, and it's completely free to use. All right, the next step is to plan for the best and hope for the best. And so that's, again, you've got your team together, you've determined your site solar assessment, and now you're going to do your preliminary plan review, whether that's new construction or on an existing home. You're going to be working with your team after you made your commitment to look at the plans and to say, what do we need to adjust to achieve no utility. For residential homes, we highly recommend the use of the Home Energy Rating System, or HERS Index rating. There are other tools out there that are helpful. This is probably, I think, is being used on 1/3 of all new built homes and major renovations, even multifamily low-rise projects, through REMrate and through ResNet. And so this is a great tool to get together with your energy assessor, energy efficiency professional, and have them assess the plans as they are, and then where you would like them to be, so you can achieve zero energy. Or if it's an existing home, you assess the existing home where it's at, and then where you want it to be. And by the way, hitting a HERS of 0, which is a lot of people think is how you get no utilities, is not necessarily the case. We've seen homes like Grokoff's, the one I just showed you at happyhome.how, at 35, that still achieves zero energy, and we've seen homes that are in the -2 that do not achieve no utility bills. So the HERS index is a great guide, and then you've got to work with your rater on the back end at the fuel summary report that we'll go over a little bit later, on what those real numbers that you're looking to go after. But what they're going to do is they're going to use this tool to assess where the home is at, and then give you a list of recommendations based on your plans, your specs, or your existing home. And then you're going to come back and get the bids back in and say, well, what is going to be the cost to make those improvements, and then be able to make an informed decision right there. Again, a lot of folks will try to approach this where they'll take the energy rating and do it at the end rather than at the beginning, hoping that they pass the test. And I would say that is a recipe for failure unless you've gotten really good at designing zero energy and you know what you're doing. So work with that energy assessor at the beginning. That's their real value in the preliminary plan process. So again, what they're going to do is raw plans and maybe some specs, give it to the energy modeler, and then they're going to make the recommendations, and then you might say, well, we need to go back and go through the specs and plans and change for the energy goal and the budget, and then they'll take a look at it again and say, okay, here's what your new energy score is, and then on and on it goes. You might have to go through a couple different iterations to get it right to fit your client's budget and to fit the model. But then eventually you should have a model that zeroes out on the fuel summary report to 0 or negative, and then boom, you should be ready to go to implement the project. The next recommendation we have is to take advantage of passive solar income. And a lot of times we unfortunately see that most projects work against the sun instead of with the sun, and so they get overheated or they don't take advantage of the free heating in the wintertime as opposed to taking advantage of it. So this is pretty straightforward. It's just understanding design and a lot of different, like Revit or Google software, many different softwares, understand where the sun is going to be at based on where your project is, and will help you give you design applications to keep the high sun out during the summertime and keep the low sun in during the wintertime using overhangs and other strategies. This is a LEED Platinum project up in northern Michigan that almost achieved zero energy, but that hot tub right there is holding it back. So a few more panels and they might be able to get there. But anyway, you can see a couple different strategies they used is this long sort of build here that's facing the south. They've got the overhangs up here at the top. They've got a white reflective roof. They've got the solar, and then they've got sun kind of coming into these windows here. So in the wintertime, the sun is way high up in the summertime, and it's not getting into the house. And in the wintertime, it's coming in very low and lighting up the house and then heating up the house. So you can check. We have a whole YouTube series on the construction of that house. Check out brainright.com. This is another project in West Michigan that has achieved no utilities over its lifetime. One thing that they did here, as you can see during the construction, is they've got these light shelves that they've put in to help brighten up the house and again take advantage of the sun coming in. You can see on their plans here that this is the south side down here, and you can see some light shelves that are designed to get the light into the kitchen, designed to get the light into the bathrooms here. And so that's, again, just a simple thing, a little bit higher cost than just drywall, but that helps lighten up the house and takes advantage of some of that heating in the wintertime. So again, here's just another example, and this is one where it's just showing the thermal mass substrate that is warming up during the wintertime and then radiating that heat off at night, when you need it. And so this is another home, again, that we documented from construction start to finish on our YouTube channel called the Sumac Grove. And this house, once it adds solar on this side, will be a full no utility bill home. But in the meantime, you can see the design strategy, another long house, again, with a lot of glazing on the south side, less glazing on the east and west side, and barely any glazing. I don't have a picture, but barely any glazing on that north side. So again, it's inviting that warm winter sun in and then reflecting sun out at least for our climate zone. There's of course other strategies you would be using in warmer climate zones. The other thing that this building and then the other building I showed you from Stanwood is that they used insulated concrete forms. So this is concrete on both sides, and then you've got foam on both sides, and you've got concrete in the middle, and then these also serve as a thermal mass. So they keep the heat out, they keep the house really tight, but then they can also warm up if sun hits them just right. There's other more natural. Concrete obviously uses a lot of energy to produce. There's awfully more natural applications that you can use to do this. Straw bales, straw clay systems are becoming more popular, assuming they're built right and can keep the moisture out. Even in our climate zone where it's very moist, We have a whole session on building with natural materials in cold, wet climates that you can check out on our website. But these are other systems that use thermal mass and use the heat of the sun to help keep the house warm. Another thing that's important is right-sizing your space. So at the end of the day, the larger a home is, the more energy demand that it's going to ask. So, so bigger homes are going to demand more heating and cooling. And so to reduce the energy of those homes and get them to no utility bill homes, you're going to have to spend more money in the insulation, air sealing, heating and cooling, and/or solar. So what we recommend are not tiny homes. I don't think that's a solution. It's a great idea, but we don't recommend tiny homes. We're recommending right-sized homes and right-sized spaces so that you can design the home down but make it more efficient for your customers, and that it has less heating and cooling spaces and therefore has a better chance of hitting no utility. So basic concepts like multi-use rooms and furniture, open floor plans, using storage under the stairs, foldable furniture, eliminating hallways. These are all great ideas, and you can go online and check out more resources there, and we hope to do some more sessions on these concepts. Suzanne Sazanka's Not So Big Home, Not So Big House was always very popular. And then if you check out Urbaneers in Grand Rapids, Michigan, they've got some great strategies that you can use that they're designing and testing for right-sized homes. This is one of our lead platinum projects, and it's a passive house in Wisconsin that has achieved no utility costs. And they have some designs on their website that you can take a look at that go from 600 square foot plans up to 1,500 square foot plans that show just the concepts of right-sizing homes and then achieving tight building envelopes and ultimately getting the home down to zero energy. So the next recommendation is having a better building envelope. So having a thermal boundary that keeps heat out. Especially in our cold weather climates where there's a lot of convection, especially on existing homes, you've got to air seal, air seal, air seal. That's the #1 thing you have to do, and plug all the leaks. So Energy Star has some great recommendations on how and where to do that. There's lots of leaks all over homes, even in newly built homes. Getting those leaks plugged up is the #1 thing you can do to keep heat in and stop wasting energy. Keeping ducts in unconditioned space is also another great idea to ensure duct leakage costs or duct leakage isn't happening as well. Second to that, of course, is massive insulation, and we're talking insulation from the bottom all the way to the top and around. And there's a lot of good recommendations on what you should do. There's the Energy Star version 3 program all the way up to Passive House, which some argue may have some diminishing returns, but it does give some good starting points and recommendations for your climate zone. Green Building Advisor has the Pretty Good House, which gives recommendations in certain climate zones on where all these R values should be, but you need to have a fully insulated and air-sealed house. That's really at the end of the day, the more you can put into the shell, the less you're going to be spending for your clients on extravagant HVAC systems, and the less you're going to be spending on solar. And so that's something your energy rater is going to be showing you in the model that they did. While you're in that, you can do advanced framing, which can reduce the cost of lumber and the strain on materials. So we're talking 24 inches on center, California corners. There's all sorts of resources online on how to do that. You can do staggered studs. And so these are all strategies that can both reduce materials and then ultimately reduce potential thermal bridging. You can also, of course, to reduce thermal bridging, you can use either a foam or a rock wool type substance in between the stud and the siding. So you can see here, there is nothing stopping that insulation or that thermal bridge there, so heat's just getting sucked out of the house. And then here you can see that they have some sort of rigid foam, or you can see that there's other applications you can use to stop that thermal bridging. And this is a great article here from Green Building Advisor on outsolation and the concepts of moving the insulation from the interior to the exterior, which is becoming a lot more popular. And interestingly, on this one, they are using a non-foam substance, so there's been a lot of interest in foam-free design, using a rock wool product that is actually rated to not rot if it were to get wet. And also, it's permeable, which allows water to move in and out of the building, which can have other positive applications on it. So this is one of the projects just outside of Minneapolis called the Passive House in the Woods. It was certified both Passive House and Green Star Gold, and we verified that it has achieved the Zero Energy Hero Award from 2010 to 2015, still checking on last year. This project, exterior walls, windows, doors, slab, and roof design according to the Passive House principles, which radically reduce the amount of energy used to condition the building. The exterior wall assembly of the Passive House in the Woods consists of 11-inch insulated concrete forms for the structure, an 11-inch exterior insulation and finish system, EIFS, facade with an overall R value of 70. The windows and doors were Passive House certified and had a solar heat gain of 64%, triple pane low E coated glazing, as well as insulated frames for installed R values of 8. The slab sits on 12 inches of foam insulation with an R value of 60, and the flat roof utilizes an average of 14 inches of poly isocyronate, I'm saying that right, with an R value of 95. So again, you know, a project like this, you need to work with your energy modeler because there are opportunities for what we would call diminishing returns and trade-offs. So sometimes following Passive House is going to get you some really good ideas, but you might find now that the cost of solar has come down, you know, an R97 in the attic just doesn't make sense. It made sense for them at the time when this was built several years ago, but there have been a lot of innovations during that. But it is great to see that, you know, again, they've helped lead the way. The next recommendation we have is to eliminate combustion and right-size your systems. You know, obviously, you cannot offset gas combustion or propane or oil. I mean, you can offset it with generating more energy. But you can't, you know, you can't get a negative utility bill when you're paying for gas. There's also some other issues in regards to combustion that have to do with health issues, you know, issues of environmental issues from you know, exporting and extracting natural gas. And so you certainly can, you know, net out at the end of the year and achieve zero energy with combustion. But our biggest recommendation is to consider looking at all electrical systems to eliminate that. So the first step is, again, you've been working with your energy modeler, your team has made the commitment, you've designed the house down really low for the energy, the thermal envelope and the air sealing. And so now you're going to work with your HVAC contractor to get a heating and cooling load. The most popular one is called the Manual J and the Manual D to do this. And what they're going to do is they're going to say, how many BTUs is this house going to need at its worst case scenario? And a lot of those same inputs that the energy modeler has are also what the HVAC contractor are going to need to determine the size of your heating and cooling system. From there, you need to determine what kind of heating and cooling system you want. At the top end, geothermal, that's the Cadillac, is going to be the most expensive. And I believe the subsidy for it has run out. So geothermal is not a renewable energy. It's just an energy efficiency strategy that takes the natural heating and cooling of the earth and uses it to step up electricity, uses electricity to step up the heating and cooling. And it can also produce not only heating and cooling, but it can produce hot water as well. So it is a great integrated system. There are a lot of costs for drilling horizontal, and if you have to drill vertical in like a city application, it can cost even more. And especially if you're doing a renovation, it might not even be legal because you have to keep the drilling away from the lot lines in more urban and even some suburban situations. But at the end of the day, geothermal technology is going to be the most efficient on the market and probably one of the most durable, long-lasting, all-electric solutions that can also that can dehumidify the house, create as much hot water as you need, and be 100% all electric. Second to that are ducted heat pump, air source heat pump systems. So these systems can be integrated into existing ductwork, or they can be built into new construction. And so these basically use air source geothermal technology, but in the air. So they're a lot less efficient, but they're a lot less expensive, especially for retrofitting. They can also be integrated with gas systems and dual fuel systems, and I think a real popular one that we've been seeing is the Carrier Green Speed, so that it can operate down to 30 degrees, but then the natural gas, high efficiency natural gas furnace system kicks in from there. And so we have seen some zero energy homes pursuing that sort of hybrid approach. These systems, also can, are becoming cost competitive in regards to having a full-blown air conditioning unit and then having a high-efficiency natural gas furnace. In smaller homes, they are using mini-split systems. So these are devices you might see in a commercial building, but you can have a couple placed around the house strategically at a much cheaper cost than those fully integrated air source heat pumps I just showed you. To heat and cool the home, and they work together obviously and communicate to make sure that the proper temperature is being used. Obviously they are, I'll say ugly, and so there are strategies. You can see it's hidden behind the wall here, hidden up in the wall here, hidden on the side of the wall, that can be done to hide some of these units. This is a project by Habitat for Humanity Grand Traverse. It's a community of zero energy homes, or near zero energy homes, where it's also a LEED Platinum certified community. And we're working with them to get their homes down to no utility costs to help serve their residents who need the help the most. But you can check them out on their website. One thing they did is they are using mini splits in this project. And one lesson learned that we'll be documenting in a documentary here soon is that first of all, they had originally used mini splits that were not designed to low temperatures, and so there were some failures occurred. And then second, up in the upstairs, they had mini splits that were not getting into all of the rooms when the doors were being shut, and so we had a lot of cold room problems. So one of the solutions that they had immediately to fix that was transfer grills and undercuts in the doors. But moving forward, they're going to be using ducted mini splits, which also exist on any further projects. There are other solutions to that are being innovated. One of them is called the Total Comfort System from Panasonic. And you can see the goal of this system. You have ideally just one mini split head, which keeps the cost down. And then you use very efficient, very quiet bath fans to help distribute the air around the house, and then you've got an ERV that's bringing in energy efficient and constantly fresh air. And so that is one solution that is being pioneered. So you basically, instead of having expensive ducts, you've just got these fans that are moving air around the house. And so that could be one solution to some of those problems with cold rooms. You've also got highly integrated air-to-water source heat pump systems that are coming on the market. And so I would say air-to-water source heat pump is the sweet spot between air source heat pumps and geothermal. It's going to cost a little bit more than those mini splits or integrated air source heat pumps I showed you, but it's going to cost significantly less than geothermal. And the efficiencies of these systems we're seeing is coming up on par with geothermal. So this is a system that's being pioneered in many different aspects, one with a local HVAC consultant that we're working with here in West Michigan. But the concept is with just almost just above code construction on the thermal envelope, an integrated system like this that works with a solar powered water heater and perhaps uses radiant heating through the boiler, could actually heat hot water for the house and then also use it to heat and cool the house, as well as dehumidify and move fresh air around. And so there are more of these integrated systems coming online that you can check out and that we'll be doing more education about. Getting into water heaters, there are now heat pump water heaters that are coming down in price, and especially in colder climates during the winter time, They will use the waste heat from gas furnaces, which hopefully you wouldn't have in a project like this. But during the summertime, they can dehumidify the house, and they can do it much more efficiently. Obviously, you need to consider the room that they're going to be in, because they will suck all the all of the temperature out of that area, and I did hear that they can be pretty loud. But again, there are heat pump technologies and water heater that are becoming pretty popular. Other thoughts that we see are point source, all-electric on-demand water heaters that are placed strategically around the house. Energy Star certified, 99% efficient, and you only use them when you need them. So if you turn on, your bathroom water faucet or your shower, it's only pulling demand from that system, so it can be sized very small and use electric very efficiently, and it doesn't affect the rest of the house. If one were to also break, you wouldn't lose, like if your water heater goes down for your client, they lose all of their water, hot water. But if one of these goes down, you still have hot water in other applications. So we are seeing more products like this coming on the market, and using a approach like this, which also can reduce plumbing costs. For the dryers, actually Energy Star does certify dryers now, but even beyond that, for no utility bill homes, we're seeing heat pump dryers, which kind of again work just like pulling the heat out of the air, and heating and cooling drying very efficiently, or condensing dryers. I had a condensing dryer for 4 years. It worked fantastic, and it just condenses the water and puts it right into the same place that the washer puts it. Another benefit to these dryers is that they are eliminating the hole in the wall that you would use to vent. So again, anytime you can eliminate a hole, you are reducing wasted energy, and so that's the other benefit of this, is that you're going to reduce your air changes per hour by eliminating that vent exhaust that would otherwise be needed for a conventional dryer. All right, our next recommendation for no utility bill homes is to avoid heating the outdoors. This is me in my older home that we had that was Green Star certified. I can't say it was zero energy by any stretch of the imagination, but it was pretty tight. And so what we did is we brought in an energy recovery ventilator. There's many different ERVs or HRVs on the market. This one happens to have a wheel on it, and so that's just me replacing the filter in the wheel. But what these systems do is they act like lungs, and especially in no utility bill homes that are going to be super tight. And so when you have a super tight home and you're not in a climate that allows you to do passive ventilation all the time, you're going to need an energy recovery ventilator, heat recovery ventilator, or something that constantly brings in fresh air and then exhausts the polluted air in the house. And hopefully you're using strategies that make the house less polluted, but we can get into that in a different session. Anyway, these types of systems are going to capture somewhere between 70 to 99% of the waste heat in the winter, or wasted energy in the summer, that you're going to be sending out of the house, and be putting it back into the home. And so that's very important in a no utility bill home. You got to get really picky with that. So here's a system that just got launched from Panasonic called the IntelliBalance 100. And so this is something that can be integrated into a smaller home or a multifamily building. And instead of having to run ductwork throughout the house, it can serve the entire house as far as exchanging fresh air in an efficient manner. But if you do an integrated HRV or ERV system, a couple other benefits for that is that if you do it right, especially in a new home, you can eliminate the penetration of the building for both the bath exhaust fan and the kitchen exhaust fan. So you can use these systems to ramp up a little bit higher when you need bath exhaust and when you need kitchen exhaust, and you can work with your HVAC contractor to design the proper air turnover in the kitchen. So number one, you're eliminating, well, basically what you're doing is you're eliminating the bath fan holes in the roof, and you're eliminating the kitchen exhaust, which is going to save money on supplies and materials and labor. And then it's also, again, going to reduce air leakage and help you hit the higher or lower air change per hour rates. And again, this is just another solution as well. That's what I would say beyond an ERV or CRV. And we're going to be doing a session on this here coming up with the Serve Build Equinox system. But these are smarter and more efficient systems that not only bring in fresh air and capture waste heat and expel polluted air, but they do it intelligently so that they're only running when they detect pollutants. So detecting carbon dioxide in the air, which by the way has a direct correlation to how well you feel, especially if you work out of your house. More carbon dioxide in the home can lead to reduced worker hours. It's also going to detect pollutants from like formaldehyde. It's going to detect other VOCs from the paint or anything from cooking, and so it's going to ramp the system up. And so therefore it's running minimally to bring in fresh air and using less power and then ramping up when it only needs to. So it's a smarter system, and it actually comes with air source heat pumps. And so there are some homes that are going to be experimenting with supplying the whole energy heating and cooling just through the heat pump integrated system with this, and avoid even using another HVAC system in place of it. And so they're going to be putting that in a pretty cold climate, and we're going to be following up to see how well they do. But that, these are 3,000, 4,000, I believe, BTU load systems. And so, that's pretty low. And so if it does work, that certainly could eliminate, a significant amount of costs on HVAC systems in super tight homes. All right, so we have to ask, we've kind of went through some of the real basic stuff that happens during the design phase, but we're getting into the real nitpickety stuff here, and we do have to ask that, the design team and the builder work with the homeowner or tenant to get really, really picky if you're trying to be no utility and save money. And so some of this stuff you might just think, well, this is just getting too extreme, but you've got to be really picky if you want to, if you want to make money or pay nothing, or if your clients want to pay nothing. So again, power strips, keeping things unplugged, having energy management plans, tracking energy usage of the house, tracking the plug loads, understanding where each plug is using energy and how to eliminate that. So having an energy plan in place to track the house throughout the year, and having a budget in place to say, okay, if we're going over our energy budget that keeps us no utility, where is that failure coming in? Is there a light being left on? Is there a pump that's running? Does somebody keep leaving the door open? Like, what's causing that to happen? And then, of course, having programmable thermostats so that you can ensure that the house is only heating and cooling when it needs to be, and not when someone is there or when they're not there. Other ways of getting picky, of course, all LED lighting, but at this point we're asking to go beyond that and to consider, are you overlighting the room? And there are tools out there like the LEED program and a few other that actually give recommendations on how many light bulbs you need and what your efficacy is per square foot to say if a room is being overlit. Now, obviously, your clients might have different needs, and we've seen people who want incandescent bulbs in their house because they give out, the warm heat in the winter. And so, yeah, these are all things that you'll be working with your client on. But overall, trying to not overlight a room can also help reduce costs and need for more switches and what have you. Having motion sensors so that when your client walks out of a room and they're not in there for 5 minutes and they forget that they left the light on, there goes energy. So that's just an easy one. And Lutron's got some great products. There's other organizations that have it. And then also getting into photo sensors. So when the sun comes in and you've got a cloudy day, or you've got that sun sort of coming in and out, and you've got the light on, the photo sensor is going to know where your client wants the light to be at, and it's going to dim that light as the sun gets brighter, and then brighten that light as the sun gets darker. And so again, this is just real cool technology stuff, but it's a very low amount of energy that this is going to save. But after you've done all the other items we talked about, this is where you start to get really picky. And then we also recommend considering outdoor lighting for your client. Overall, we've understood that lighting a space outside actually could make it less safe because that gives somebody with ill intent the ability to see. And so those are things to consider. The other thing is to consider is certified dark sky lighting, which is not only going to save energy, but it's going to help reduce light pollution, which is currently ruining most of our view of the galaxy. And I suspect, I would hope someday we get that view back, but it's been gone mostly. And then continuing, Energy Star appliances, trying to go for tier 3 if you can. That's some real easy stuff to do. I would say up-down fridges are really the best way to go. From studies being done, side-by-side fridges, even if they're Energy Star certified, use a ton of energy. So getting the freezer on the bottom or the top is actually going to be more efficient. And also, if you've got ADA compliant or universal design clients, or you're just trying to do the right thing and design the house from the beginning the right way, it's actually known that the up-down fridges usually are ADA compliant as opposed to the side-by-side. All right, so getting into cooking. Electric stoves use a lot of energy and they cook terribly. I think we can all agree there. Gas stoves have been the sort of go-to, but they also, as you know, we use a lot of waste heat. And so that's a lot of energy being wasted that doesn't need to be. So Grokoff, you can go check out his website, happyhome.how, I just showed at the beginning. You can see a couple videos of him on his gas stove and everything melting around it, and then he swapped it out for an induction stove, and you could see instantly reduced the heat around the stove. So what induction does is it uses magnetic pans to only heat the pan, and you can get rapidly boiling water immediately. This can also prevent burns from kids touching the pan. And it's, if you have clients who love to cook and love to entertain, famous chefs are, saying induction is the way to go, and that they either prefer it or say it's on par with gas stoves. So, and the costs are coming down, and again, I don't think induction stoves are being considered in energy models right now, but it's just another way to get really picky and ensure your client, hits their goals of no utility bills. All right, so this is the www.netzerominnesota.com. This is a project that is pursuing International Living Future Institute Zero Energy Certification, our Zero Energy Capable Program, Green Star Gold, and LEED version 4 Platinum. Very excited. Documentation is underway, but you can check out the owner's blog and what they've done to achieve zero energy. They are actually on track, which is very exciting. This actually just popped up the other day, and it just, one of the things I wanted to point out is this idea of monitoring and measuring. So you have, if you have a budget, if you have a financial budget, you're monitoring and measuring and trying to understand your goals and where you might be missing them. The same thing is being asked for folks who want to achieve no utility bill homes. So what they've done is they're monitoring their production, their total consumption. They actually have electric cars, so they're monitoring that usage, their HVAC system, and their appliances. So they're getting a fairly good understanding of where their energy is going, and if there's an issue, they can adjust it. So you can see, I think actually since July, they have been trending to more production through solar than consumption. So we would say they're pretty good on track for a no utility bill home, but we'll be following up with them and hopefully doing a Facebook Live tour of their house here soon. But you can see in January, that's where they finally went over. And really, that's probably due to the fact that it's Minneapolis, it's climate zone 6, and it's freezing. And so you're only going to track net usage during the fall and the spring and the summertime, but that's where that's going to make up for that loss in the wintertime. But again, they're monitoring it and making sure that they're on track. Another way you can help your clients out, especially if they have home offices, is to build out a power plan with them on their computers and have them set that up. Again, just getting real picky here. I've been doing this for years, and I know I would always, in my computer lab, set the power plans off to shut the screen off after 5 minutes, and I'm sure it drove people crazy. But again, your computer is, most of the energy your computer is using, or your monitor, your TV is when it's on. So if you help your clients set up a power plan that so when they walk away from their computer after 2, 5, whatever, it blanks out. 70% of the energy use is gone. And then it could go to sleep after half an hour, and then 99% is gone after that. And so again, this is just another way to work with your client in the design, or when you're putting the homeowner manual together, to get really, really picky and say these are some things you should consider that will help you achieve no utility bills. All right, and last but not least, after you've done everything else, now you want to look at solar, right? I mean, at the beginning, you looked at hopefully what your solar production can be on your site, with PV watts, with your solar energy expert. But now, sort of the last thing you're going to do is put hopefully the smallest amount of solar on, because at the end of the day, solar is still more expensive than all those other things we talked about for the most part. But solar is the #1 growing energy, added energy production across the globe. It's unstoppable. And so solar PV is something that is becoming a lot more popular, a lot more affordable, a lot more easy to access. This is a home that is LEED Platinum and Zero Energy Capable certified in Chicagoland. It's sort of a side product of a builder. They have sort of their EcoSmart line. And so we'll be tracking the data on this one for the next year. But again, they were able to design the house as low as they can using these other strategies, and then putting solar panels on to make up the rest. There's still a 30% tax deduction available for solar PV for your clients. That's good through the, hopefully good through 2019. And overall, I just want to be clear that we're advocating for solar PV for many different reasons. Wind is only good, from what we can tell and from whenever we talk to, that if you're on the lake shore, or if you own a lot of land and you can get the wind turbines up very high. They're really only good for utility scale programs or out in the water. Wind is not a good personal thing to put on a house. It's never, ever going to have a payback to it. And so we just don't recommend it. The other thing is, because of the energy efficiency of devices, many of the devices we just spoke about, heat pumps, you name it, thermal solar, hot water solar, is just becoming, I mean, a lot of solar folks we've worked with just stopped doing it. It's just too expensive for the plumbing. There's failures. And at the end of the day, if your client overproduces hot water, they cannot send it back to the grid and get paid for it. Like when you overproduce PV, you actually have to dump it, and it becomes a problem. So we just don't recommend solar thermal anymore. And it may have its use in some applications, but we just don't see it. The other neat thing about solar is that there's integrated solar roof systems from companies out of Michigan that have been on the market for the last 15 years. There's other solar integrated roof systems that are coming out from big organizations you may have heard of that are making huge promises that they'll be on cost or on par cost with conventional roofs. So that's the ultimate goal, is that every single new roof that goes on is just an integrated solar roof. Some of these applications can pick up the tax credit both for the roof and for the solar in itself. And so therefore, you're getting a 30% deduction on the whole package. Some can, some can't. You have to check with your tax accountant and the details. But again, if you can do it all at once, or if you can put an integrated solar roof right on top of existing shingles and not have to pay for the deconstruction costs on an existing home, that's a great way to cut costs and help make no utility bill homes make financial sense. So for batteries, again, this study just came out in Nature, I guess, and I'm not sure if you can access it without paying for it, but one of the premises or the conclusions of this study was that homes that were solar and on the grid, so feeding into the grid, actually used or produced more energy than ones that were feeding into a battery. And so we're not talking about battery-powered homes in this program. Obviously, if you wanted to have no bill whatsoever, your client would have to use batteries. And I think batteries are also a great strategy in case the power goes out, because you can't use solar when the power goes out. And they're also, a great strategy if you've got demand pricing in your area, where prices are higher in certain areas, because then you can pull from the battery. But currently, batteries are still pretty expensive. They can be pretty toxic. And, there are cradle-to-cradle certified batteries that I've been seeing coming out. There are salt batteries that I've been seeing coming out, and other promising batteries that have been coming out. But this was an interesting study to show that it might be more favorable to stick with the grid for now. And of course, depending on where your project is at and where your client's at, you can get paid for staying with the grid. All right, and so my last point here is, if you remember at the beginning, we said you need to work with that energy modeler, that energy assessor, that HERS index rater, passive house rater, or green rater, to help you design your project. Well, also what they're going to be doing is they're going to be testing and inspecting it. So if it's a new construction or major renovation, they're going to be doing pre-drywall inspection, testing, making sure everything was done right. And that's very important, because a lot of times things can be done wrong. And so they're there for quality assurance to catch those issues. They're doing duct blaster testing, they're blower dooring the house to find leaks, insulation inspection, they're inspecting the heating and cooling equipment. And that's all very important to ensure that that's all done correctly and proper. And if there is an issue, it's best to solve it now before you hand the keys over to the client, and then they have to call back and there's a failure. So that is one of the second value adds to these energy efficiency professionals, is coming in, doing the model, and then coming in and inspecting it during the design and construction phase. At the end, what they're going to do is, based on their findings, they're going to update the model. And if things have changed, it might be in your favor, it might not be, but they're going to update the energy model and tell you where your final energy usage is at. And so for many of these certification programs, reference zero energy capable, living building, you name it, this model is kind of what gets you proof that your home is going to be a no utility bill home, and helps give your clients confidence that if they operate the home correctly, that they should be able to achieve no utility bills, assuming there's not a strange or odd year that occurred with weather, which can happen. So here's an example. This is a home down in more of a not warmer climate, but certainly not Minneapolis. This is actually a whole development called Revive in Fort Collins, Colorado. They've got single-family homes, single-family attached, multifamily. They've got duplexes. They've just recently been recognized by the Department of Energy as a 2016 innovative home and got an award for that. And the local Home Builders Association chapter in 2015 gave this project the Best Green Design Award. We honed in on actually the developer's personal house, and very thankful she shared with us a bunch of data, and we were able to confirm that her house has achieved both zero energy capable along with the Zero Energy Hero Award. And so I've got a couple. This is their certificate here, their Energy Star certificate, that comes after you get a HERS rating, and you can see they got a -9 HERS index rating. But I wanted to zoom in on the sweet spot here of what we're really looking at is your MMBTU loads. So you can see here's their heating, cooling predictions, hot water, lighting appliances, and then their PV. It is interesting, but what you're going to see in these newer homes are lighting and appliances becomes the big load, and hot water, cooling, heating are all going to start to diminish in these types of homes. But here's what we're looking for, I think, is if when you're doing the design phase in the preliminary model, you want to see a 0 or a negative on here to really know that your client's going to be on track for a zero energy home. It's not always the case, but I think that gets you into a more comfortable position that if they operate it correctly, they should be able to achieve that goal. And so here we also took a look at her utility bills just for this particular project. We're going to be looking at all of the homes here soon. And here is what they used over the course of the year. And here's what they produced in solar. So you can see a net production of 2,000 kilowatt hours. And so they don't have any gas either. And so what's interesting here is we also hear a lot of complaints that these energy models are just way off. And there are times, garbage in, garbage out. But the case in this one is if you convert this negative 7.8 MMBTU to kilowatt hours on any conversion tool, it's going to come in somewhere around 2,200 kilowatt hour prediction. So it's predicting that the house will use will produce 2,200 more. And so you can see that's within 200 kilowatt hours of what they actually used, at least for this last year. So in this case, the models, I would say, relatively close. You'd have to forgive them for being off by 200 when many of these are off by 10,000. So very, very excited to see that come through, and I wanted to share that finding with you all. So it's now 4 minutes past the hour, and I want to thank you all. I saw a couple questions come in, and I'm here for some more time to take some more questions. Real quick, for those of you looking to get your live continuing education units, a survey will pop up at the end of this session. Make sure to take it, or it'll come in email. Just take one of them. For those of you watching on demand, please get the 80% passing rate. Huge thanks to all of our sponsors, Sun Intuitive, Self-Tinning Glass, Niagara Conservation with 0.8 gallon per flush toilets through Stealth, Build Equinox and the Serve, Panasonic, and Certainteed Air Renew formaldehyde eating drywall. Thanks to all of you for watching. Thanks to our 50 members scattered across the country and our board of directors. We certainly could not do these sessions without your help. All right, so a couple questions have come in. On right-size homes, what is the cost per square foot? And do these homes appraise at a level to qualify for financing to do the construction? That's a really good question. Sometimes you have to ask, some of the smaller homes, they're not even legal. Some jurisdictions you have to build homes to a certain size. And one could argue that's too big, too small. It's very subjective. So we have seen a lot of advocacy movement that have been trying to get homes to be able to be built smaller, just in general. And then, yeah, there is the case of concern of, what is the appraisal value, and are they going to, appraise high enough? Obviously the house is going to come in under the market if it's a lot smaller, depending on where it's at. So you have to talk to your specific lender. But that is certainly a good question on the financial side, and I hope we can get to answer some of that more in sessions that we do based around right size housing, because I don't have the exact answer there for you. Okay, and then so there was a question about the organization Matt Grokoff with the Mission Zero Home, and that is Happy Home. It's a pilot website that Google piloted with Matt of the Mission Zero. It's happyhome.how. I'm sending it in the chat, and it's also in the handout. I do recommend that you check them out. Are you big on energy monitoring systems? I just purchased Site Days for a project and haven't been able to spend a lot of time researching it, but I will soon. Wondering if you have any input. That's a great question. I think as I mentioned, I think getting the design down, the loads down, getting the right size solar is sort of easy stuff by now, but the real hard stuff is having these appropriate energy monitoring systems that work. And I haven't had any experience with any that I can off the bat recommend. I've been seeing a plethora of startups approaching this. I've been seeing some really exciting ones. I had a conversation with a company where they have their boss's home being monitored, and he's like, oh yeah, my boss is home right now. I can tell someone's in the bathroom because of the energy use there. And he's like, let's try something out. He fired up an electric heater in the house, and it just showed how much energy that thing was just pulling. And he's like, this is just a good example of what kind of data this system gives. And it kind of gave a really cool visual, and then it showed the the usage that just spiked. And so, he said someone could pull that up from their smart home or their smartphone and even control the house from, wherever they're at. So we are seeing more and more of these systems coming online. I know a lot of the solar systems that are being installed sort of come standard with this stuff now, because obviously most people want to know what they're using and make sure it's producing right. But, again, there's nothing, I can't recommend any specific systems. I haven't seen anything enough or talked to anybody enough to say, one works works better than the other. I know that the EcoBee does a pretty good job of monitoring HVAC as well as, I think, plug loads, and you can learn more about that at that Grokoff site on happyhome.how. So the question is, and it's a great question, could you provide or point to studies that document with hard numbers the economic relationships, benefits, and liabilities of the various net zero or substantial construction practices and analysis? So I think that's really where we're at now, is all of these homes are kind of coming online across the globe, and we're monitoring the homes to make sure that they're no utility bill homes. But then we're also taking a look at their costs of construction versus the relative homes. And then we're also looking at the, any kind of durability or maintenance issues for upkeep, and if it's any bit higher. And so there are need for that kind of study to be done on the costing of this kind of stuff. Just roughly, I've, seen different reports and talked to different folks, and we're seeing at the highest zero energy homes, assuming you've got the right design team and you put a lot of upfront thought into it, can come in just 10% over conventional homes. The other thing that we're seeing with lenders is that they know, so smarter lenders and other programs like Property Assessed Clean Energy programs know that, if they lend you more money to do a zero energy or no utility bill project, that the client is going to be paying less or theoretically nothing or making money on their energy bill, and therefore they can eke out a little bit more in the cost of the mortgage or cost of the PACE loan or whatever, whatever system you might be using, whatever financing mechanism you might be pulling together to achieve this. And so they're very smart and say, okay, we know that you're going to be paying less on your bill, therefore you have the ability to pay the higher premiums on the mortgage. In low-income housing situations, this is becoming a no-brainer. These folks don't have much money to spend on energy. They're spending way too much on energy. And so a lot of Habitat for Humanities and other organizations are saying, why should they have any utility bill? And now they have more disposable income. So that's just starting to make a lot more sense in the financial world. And then we've seen other situations where projects have come in, twice over their costs, and many failures have occurred. And so there's a lot of, a lot more information that we still need to see on the financial end of this, and more studies that need to be done. It's a huge need. So. And Glenn, I'm glad you brought that up. I was going to say that, and I forgot to mention. So the question is, what about home appraisal? Is home performance considered in the value of the home? So that's the other end of that. So again, the lender knows that your house should be worth more money if it's green certified, ideally, and is a proven no utility bill home through one of these verification programs. Or, just take a step back from that for a second. There was a study done in Chicago where homes that just simply disclosed their utility bills didn't even necessarily have better utility bills. They just were more transparent about them, sold higher and faster than the homes that didn't do that. So if you can imagine, if we've got more transparency and we've got homes that are having no bill versus ones that do, you're going to get more value out of that. They're already showing in some places green building certifications are driving somewhere between 1% to 10% more value of homes. Solar is driving somewhere between 5% to 10% more value of homes. And so there is that increased value that's going on. And so again, the lender is starting to feel more comfortable knowing that, if something were to go wrong or you default or whatever, there's a more valuable home there that can be sold in a market that's growing and starting to better understand and demand these types of systems. Are there any other specific questions related to this? Again, I want to thank all of you for joining us. This session will be recorded and featured on our YouTube channel, and there will be a handout on our website. It will also be featured on our USGBC Education Partner channel. Make sure to take the survey that comes your way if you're watching this live. Make sure to take the quiz if you're watching it on demand. And my name is Brett Little. I'm the Executive Director here at the GreenHome Institute. If you have any questions, feel free to reach out. We hope to be doing more sessions with more experts from here on out to focus on concepts of zero energy and help break down that barrier. So we're very excited to be continuing the conversation. So I'm going to head out, but thank you all for your time and enjoy the rest of your week.